Hello everyone, this is an introductory video about DAX. So what is DAX and why do we need to use it? DAX is an abbreviation for Data Analysis Expression, which are functions very similar to the functions you may find in Excel. During this course, you get introduced to many of these functions and how to use them. For now, let's answer the second question, which is why we might need to use DAX. So whenever you create a calculation in Power BI, you have two possible kinds of outputs. The first one is a categorical output and the second is numerical. So by categorical, I mean textual values, ranks, or even dates. And numerical means whole numbers, decimal numbers, or even percentages. So if you would like to return a categorical output, we need to ask ourselves a question first to decide whether we should use the query editor or whether we should use DAX. So, if the output depends on more than one row of the same column, we need to use DAX. Otherwise, if the output does not depend on more than one row of the same column, we need to use the query editor. So let's say that we would need to use DAX. Should we use a measure or a column? And what is the difference between a measure and a column? Well, first of all, if the output is dynamic, we need to use a DAX measure, and if the output is static, we need to use a DAX column. Okay, so let's answer all of these questions one at a time. So first of all, what do I mean when I say if the output depends on more than one row of the same column? Let's take an example using the student's score in Power BI. So here we have the student's scores table, and let's say that we would like to make a calculation that shows us for each single subject, for each single student, whether that student has passed or failed that subject. So as we have a column with the actual score and another column with the past score, we can simply create a conditional column in the query editor to return this value. And we should. Why is that? Because the calculation that we would like to return does not need to consider more than one row at a time to return the value we need. Now that's an example about when we should use the query editor to create a categorical column or to create a categorical calculation. Now let's take another example about when we might need to use DAX. Let's say that we would like to make a calculation that would show us the rank for each single student in each single subject. So we have two students in that table, Adam and Mary. Let's say that we would like to know whether Adam has placed first or second in English subject. So in that case, we would need to consider not only the score that Adam has made in the English subject, but also all the scores all the other students have made within the same subject. So we need to consider that score for Mary as well. So as we need to consider more than one row to make that calculation, we need to use DAX. So the question now is, should we use a DAX measure or a DAX column? Then we would answer the question about what the difference is between a DAX measure and a DAX column. So going back to the PowerPoint presentation. So if the output is dynamic, we need to use a DAX measure, and if it is not dynamic, which means static, we need to use a DAX column. Now let's go to the Power BI for a second. So as the output we're trying to make here is static, meaning that whenever we apply any filters, the value that says either 1 or 2 should not change, we should use a DAX column as the output is a static output. What about measures? When should we use measures? And what are measures? Well, let's take another example. So going to the report view, over here, we have a table with all the student names and the sum of all the scores they have made across all the subjects. and I have a filter over here so that I can choose whether to include all subjects or specific subjects only. Now, for now, let's choose all subjects. And let's say that there is a minimum passing score of 200 that each student must achieve in order to pass the year. So you can see that both Adam and Mary has got scores, overall scores in all subjects combined, which are over 200. But if we exclude math grades, you would notice that Adam's score now is 199, while Mary's score is 208, meaning that we may say, excluding the grades for math, Adam would have failed the year, while Mary would still have passed the year. If I would like to make a calculation that shows passed or failed based on the subjects selected and based on whether the overall score shown is over 200 or not, to make such calculation, I have to use a measure. Why? Because the output changes based on the values I select from the filter. So in that case, I would add this measure over here, and it would return failed whenever the actual score here is less than 200. Now if I add math back, it would return passed for both of them. Now if I exclude both science and math, it would return failed for both of them because the scores for each of the two students is less than 200 points. Now let's answer the other question, which is what are measures exactly? So briefly, measures are calculations which are evaluated within the context they are put within. So for example, the value for the measure we have added right here changes based on the filter context we apply over the table. So if the filter context changes, the value returned would change as well. In addition to that, you need to understand that measures are only evaluated when they are used or added to a table or a visual, compared to columns which are evaluated when they are added to the table. And that's a very brief definition of measures. You would further understand what measures are and how they are used in later videos across this chapter. For now, let's go back to the PowerPoint presentation and figure out whether we should use the Query Editor or DAX when we evaluate or when we calculate a numerical output. So if we are evaluating or trying to return a numerical output, we need to ask ourselves the same question we asked before, which is whether the output depends on more than one row of the same column or not. So if the answer is no, we would use the Query Editor. If the answer is yes, we would use DAX. Then we need to ask ourselves, if we're going to use DAX, whether the output is dynamic or static. So if it's dynamic, we would use a DAX measure, and if it is static, we would use a DAX column. Let's take some examples using the same student scores table we used earlier. Now going back to the data view, let's say that I would like to make a calculation that would return the percentage each student has got in each single subject. So to make such calculation, I would simply divide the actual score by the full score. So to make that calculation, I do not need to consider more than one row at a time. And that's an example about when it would be better to use the Query Editor to return a numerical output. Now let's take another example. So that column over here is showing the total score of each student across all the subjects listed on this table. So for example, if we filter this table to show only Mary's scores, the sum of the actual scores she has got across all the subjects is equal to 286. Same thing for Adam. If we filter this entire table to show only Adam's scores, and if we sum all of his actual scores, we would find out that the sum of all of these scores is 274. Now if we remove this filter the column we were talking about before the break is that column, which is simply calculating the percentage each student has got compared to all the grades he has got across all the subjects combined. So in other words, we are dividing the actual score for each single student by the total score for each single student. As you can see, this value is static, meaning that if I go to the report and here on page 2, no matter which subjects I choose, the percentage here would remain the same for each respective name and subject combination. So for example, the percentage for Adam's scores for English and history are 25.5 and 22.6 respectively. Now if I remove math, for example, it would remain the same. If I remove science, it would remain the same. If I remove even history, it would be the same. And if I bring history back and remove English, the number here would not vary depending on the selection I make. Now let's take another scenario for static numerical calculations where we need to use a DAX measure. So assuming that we are still dealing with the same calculation, that is the subject score of total score, but this time we would like this percentage to vary depending on the subject we have selected. In other words, we want the total score to represent only selected subjects. In that case, let's go back to page 1, where I've used a measure in this table. So as you can see, we have a measure sign next to the field I have used. Now the total for each student is the same as the total we got on this table here, on this column, that is 286 and 274, which is the same number we have right here. But if I select different subjects, if I select, say, all subjects except for science, the number here would change, and the percentage of each subject compared to all the scores the student has got across all the other subjects would change, because the denominator would change as well. Now if I remove math, watch what happens. So the first two percentages we have here are 29 and 30% respectively. Now if I remove math, they will become 45 and 47. If I remove history, watch what happens for these two percentages. English score for Mary and English score for Adam are now 45 and 53. Now if I remove history, they will become 100%, because the sum of the scores of all the subjects selected would be the same as the actual score for all the subjects selected. We only have one subject selected here, that is English, so the sum of the score for English for the same student is the same as the actual score he has got. That's why we got 100%. Lastly, we need to understand that whenever we need to use an output or a value as a filter or as an axis for a visual, we should always create this value or calculate this value using either a DAX column or using the query editor. In other words, values which are used for filtering or used as axes for visuals should always be created using columns, not using measures. That's all we need to know as an introduction to DAX. In the next videos, we'll explain how to use many of the functions you have seen in this introduction, and many more. See you in the next videos. If you like this type of content, subscribe to our channel, hit like, and leave your thoughts in the comments below. And by the way, we also offer Power BI consulting and training services at www.powerbimaster.com. See you in the next video.